Okay, hey, welcome to part 2 of a tutorial about using shadow graph. There was a couple of great comments about shadow graph not being a Schlieren, which is true. There is a synthetic Schlieren type calculation, which certainly is something we're considering putting in. We'd love to hear back from the community to find out whether or not that would be very valuable. What I'd like to do is maybe walk through in a little more detail shadow graph calculations and how they apply in supersonic flow, and to show you how they compare to just a simple calculation of shock. So I'm going to take a look at this very simple case. This is flow over a diamond airfoil shape at Mach, I believe 1.5-ish, could be 1.6. And as I showed before, the easiest way to do this is to go into Analyze. You first have to go in and identify the field variables. Now, someone pointed out that the default is momentum, but in this case they actually are velocities, and so the u and v velocities you can see will auto-populate, which isn't a big deal. And we're going to use temperature and pressure as our state variables. Those are also available as static pressure and static temperature. So once you've set up the information about the flow, the calculation is relatively straightforward. Under the Analyze capabilities, one can go to Calculate Variable, and you can either type in, which might actually be easier in this case, shadow graph, and the calculator on demand is set up if you have a large data file. If you don't want to make this calculation right away, you can do so. This is a very small case, so I'll just say Calculate. Okay, and it shows me that the calculation was done. It shows what the shadow graph calculation yielded in terms of max and min. We'll also go ahead and calculate shock, so we'll just type in shock. I'm pretty sure it's shock. It may be shock feature. We'll find out here in a second. No, it looks like shock calculated. Okay. Now to look at this more in a comparative way, what we're going to do is I'm going to grab this and I'm going to right click, I'll copy, and then I'm just going to hit Control V. I'm not going to be able to show you that. I'm going to show both frames side by side using tile frames, and just puts them side by side. And we're going to actually, you can see that right now they're not linked. If I want to link their size and position, one goes to frame, and you can go to frame linking and say, oh, I just want you to have the X range and Y range linked, and if I apply that, you can see now that they move together. Okay. So on this example, we're going to look at the shock feature. So I will go over to contour by right-clicking, and we'll look at shock. And so this is the shock feature, and I'll go ahead and you can see the values here, but I don't really need that. Move that over. To make it more comparable to a shadow graph, I'm going to change my contour type. So in this case, again, I'll show this as shock. It should be symmetric. And the only thing I'm going to change about this is under contour, which I'll move this back over into view. Instead of a small rainbow, I'll use grayscale. And I'll use continuous. And we'll do that for the, in this case, we'll do that for shock. And we'll do a continuous representation of shock going from minus 1.8 to 1.8. Grayscale. And then the second contour variable, well, in this case it doesn't matter too much, but once we have that, if I go in here and change to shock, and similarly here, change that to shock, you can get a quick view of what the shock's coming off the leading edge of the airfoil. Okay, so we want to look at that in the context of shadow graph. So in this example, we'll do a similar thing. So we're going to change this to shadow graph. We'll change the coloring to continuous and use grayscale. And I can click on both of these zones just by holding shift, and I'll right click here and we'll change this to shadow graph function. Now oftentimes a shadow graph function you may need to reset your values, so we're going to do that under contour, and really we'll just change this to say minus 100 to 100. See if that picks up the shadow graph any better. And let's see here. It doesn't look like it did. You can start to see it a little bit. Okay. Maybe we'll go down in order of magnitude and see if that actually helps us refine it. Okay, so there is the shadow graph calculation versus the shock, and you can see that the key feature that we're trying to show is just the shock coming off the leading edge, and you can see that pretty well here with that calculation. And I'll just make sure this is redrawn. Okay. Again, we probably do not need the contour legend here, so I'll remove it. So what we have now is the shock feature versus the shadow graph feature for this diamond delta wing, and that's how you use the shadow graph function. Now, mind you, it's again not a replacement for a Schlieren or the synthetic Schlieren, but it's a good way to show shock like this example. Thanks for watching.